Assalamu alaikum everyone, it's Mr. Fahad. Today we will continue with the sixth lesson, derivatives of trigonometric functions. By the end of the lesson, you should be able to find the derivatives of trigonometric functions using differentiation rules. Okay, let's start with a couple of lemmas. A lemma is a small theorem that we used in proof. So the first one says limit when theta approach 0 for sine of theta equals 0. You can easily prove this using your calculator numerically, and you can see it here graphically. Now the other one is the limit when theta approach 0 for cosine of theta equals 1, and also numerically, graphically. Here limit when theta approach 0, sine of theta over theta is 1. And you can see here from the graph, sine of x over x is 1. And the last one, the limit when theta approach 0, 1 minus cosine of theta over theta is 0. And you can see it once again in the graph. Okay, so let's use these theorems. Use the basic limits, sine of x over x equals 1, and the limit when x approaches 0, 1 minus cosine of x over x equals 0 to find the following limits. And we have here about 4 questions. You can pause the video, try to do it, and then come back to check your answer. All right, so with the first one, in order to use the limit of sine of x over x equals 1, we have to multiply the top and the bottom with 3 over 3. So in this case, we will get 3 limit when x approaches 0, sine of 3x over 3x. And now I can assume that 3x is u, and whenever x approaches 0, u will be approaching 3 times 0, which is 0. So now I can just apply the basic limit here. This will equals 3 times this limit is the same as the one that we will use, which is 1. So 3 times 1 is 3. Now, in general, here's a result. Whenever you have limit of x approach 0, sine of ax over bx, then this will be the same as a over b. So you take the coefficient of the angle over the coefficient of the denominator here. Okay, so using the result with the second question, we will get 1 over 4. And with the last one, you have 1 over 5 cosine of x minus 1 over x. We took the 5 outside in order to use the limit here. So if you took negative 1 as a common factor, this will be 0. So negative 0 is the same as 0, and this will all be 0. Last question, we will assume u equals x squared, and then as x approaches 0, u will approach 0, and this will be 1. All right, let's move next. The derivatives of the 6 trigonometric functions are, so derivative of sine is cosine, the cosine will be negative sine, and derivative of the tan is secant squared. For the cotan, it's negative cosecant squared. Secant is secant times tan, and the derivative for the cosecant is negative cosecant times cotan. So you need to memorize these in order to solve the questions. Let's take an example. Find the derivative of cosine x cubed, and there's another one where the power is on the trig function itself, so cosine cubed of x. The angle here is just x, and the last one, cotan of 3x. So it's important that you distinguish and you pay attention where the power is. All right, pause the video, try to do it on your own, and now let's solve the first one. We have cosine of x cubed, and the outside function here is the trig function. So the derivative of the cosine is negative sine for the same angle times the derivative of the angle. X cubed is 3x squared. And we can arrange this to be in the final form. We usually take the numbers, signs in the front. Okay, let's move to the next one. So cosine cubed of x. The outside function here is the power. So you can rewrite this whenever you have the power on the trig function to be inside the bracket to raise to the power, okay? So it's clear now that the outside function is the bracket, or you can think of it as u power 3. The derivative will be 3u squared. U is cosine of x. And now the inner function is cosine of x. The derivative will be negative sine of x. And again, we can just arrange it. This will be the final answer. For the last one, straightforward, we have the derivative of the trig function times the derivative of the angle. That's all. Okay, moving to another question. Pause the video, try to do it on your own, and then come back to check your answer. So in here, we will start by rewriting this to be inside the bracket raised to power 3, because if you notice that the power here is on the trig function, and it's helpful to write it in this form. Okay, so the derivative here will be derivative of the power, so 3, the bracket, power 2, and then the derivative of what's inside, tan will be secant squared for the same angle, 2t, times the derivative of the angle, which is 2. And we can rearrange this. Again, take the numbers, multiply them, put them in front.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Now let's take a derivative that requires a product rule. So in here, find the derivative of x power 5 cosine of x, and another question, x squared times secant of x. Pause the video, try to do it on your own, and then come back to check your answer. All right, so in the first one, we have a product rule. So the derivative of the first times the second plus the first derivative of the second. So cosine will be negative sine of x. Now let's just simplify it. So this will be the final answer. For the second one, similarly, we will use the product rule, apply the product rule, and then this will be the final answer. Now let's practice with a question involving the chain rule and the quotient rule. Pause the video, try to do it, and then come back to check your answer. So in this question, we will use the quotient rule to do the derivative for the angle. Okay, so sine of this, using the chain rule, derivative of the outside times derivative of what's inside. Now this angle requires the quotient rule. So this will be cosine of the bracket times derivative of the top times the bottom minus the top derivative of the bottom over the bottom squared. Let's simplify it further. Now this will be 2x plus 2, so we distributed the 2, minus 2x. And now let's just cancel out 2x with negative 2x, and this will be our final answer. One last question. So in here, use the position function to find the velocity in feet per second at the given time. So in here we have the position function, and the velocity will be the derivative at t equals 0. And we can just write this in our calculator. So shift integral to into the function as the derivative at x equals 0, and this will be negative 2. Let's solve it without using the calculator. So the velocity here is the derivative derivative of t squared is 2t, sine is cosine, and the derivative of the angle is 2. Let's arrange it, put 2 in the front, and now plug in 0, the time t equals 0. That's where we need to find the velocity, and this will be -2. All right, that's it for today. Thank you so much.